Example 1 is to help you see what you should expect to do for 1 through 5 from your handout. And in this lesson, our focus is on building connections in our mind between the algebraic solution, the graphical solution, and the table that represents those solutions. So we'll start by doing the algebraic solution, and anytime you're solving an equation, a really important question to ask yourself is, what kind of equation is this? This equation is clearly linear because I see x's but no exponents. So we will begin by simplifying each side, and the first step to simplify the left would be to distribute the 5, which gives us 5x plus 15 plus 8, and distributing on the right gives us 9x minus 9. And then the one more step we need to take on the left is to combine the like terms, which would be 15 and 8, which gives us 23. And then on the right, nothing else to do but copy it. So now we're ready to isolate x, and we need to combine our x terms first to do that. And so what we'll do is subtract 5x from both sides to eliminate the smaller x term. Okay, let me try that again. And then when we subtract 5x from both sides, we have 23 equals 4x minus 9. And then we need to add 9 to both sides. And we get 32 equals 4x. And then the only thing left to do is to divide both sides by 4. And we have our solution, which is x equals 8. And especially in a problem set like this, where we're going to solve both algebraically and graphically, having your algebraic solution helps guide your thinking when you go to get your graphical solutions, because the picture we want is what you see here, but that was our second attempt, or that would be the second attempt. And let me move it out of the way so that you can see what the first attempt looks like. And that's what we see behind here, is the standard view graph of what you would see if you just typed in the equations and hit enter. Now this is on an Inspire, so you see the equations actually on the screen. And not only that, but the equations you can position, and I did that here, to line up with the ones that they represent. Now on the handheld, if you have a color calculator, the color of the equation will match the color of its graph. But this picture does us no good because of the fact that we have an intersection we're looking for that's off the window. On the Inspire, you can click and grab. On the 83s and 84s, the non-Inspires in essence, you need to go through your zoom procedures to figure out where that is. But the fact that we know our solution is at 8 tells us we're going to have to move out that way, and that's how you'll know. So now let's go back to the graph that's going to do us the most good, which was the one that was on top to start with, and I'll move it back up here for us to look at. And let me clear these notations I made on the other one. Okay, now we want to copy what we see, which is what your sheet tells you to do. So you'll have this will be like you're looking at your calculator screen, and you're going to go in and graph what you see on your paper. And you should always use a straight edge, so we will start with a straight edge for our axes. Now in this particular instance, you don't see the x-axis in your viewing window, and I'm completely okay with that. So you don't need to worry about trying to show the axis that's not showing in your picture. I want you to sketch exactly what you see, because we'll do a lot of this semester. So this is where you want to pay attention to your scale. And you'll notice, well actually you can actually see the x-axis. I was lying apparently. But here's the 1 down here, and that is in fact our x-axis. So let's go ahead and put that in there. But even if you have a graph where you've cut the x-axis off, let me undo that. I don't like that. If you've cut the x-axis off, I don't know why it's wanting to connect. I'm just trying to put it up here. So maybe let me extend it back. No, this thing's crazy. Let's see if I can it'll let me cross. That's better. Okay. But if your graph doesn't show one of the axes, you just include in your sketch for your assignment the part that you actually see on your screen. So this is 1 in the first spot down here. So we're going to go to the right 8, and we need to go up 63. Well, clearly we're not going to go up 63 boxes. And you can't really tell the scale. It's not marked very well the way this screen displayed. But let's see, 1, 2. Let's just say we're going to go by tens. So I'm going to mark this first spot as 10, and then I'm just going to count by tens from there. So I'm going to go to the right, 1, 2, 3, 4, 5, 6, 7, 8, and up 6. 1, 2, 3, 4, 5, 6. And then we're going to 63, so I'm going to go just a little past that to plot my point. And then I would use the ruler to make sure you're lining up on a decent approximation of the intercept. And you go over and count 1, 2, 3, 4, 5, 6. So the first line is crossing at just past the 6, and now we have a point to aim at. 6. So we're going to grab our ruler and run right through here and run through that point and out to the edge of the graph. And then the other line looks like it's just past the 7. So we'll go again, and again we start down here. Oops, that's not a good start. Let's try again. Just past the 7 and up through the line. So that way it looks like a decent approximation of what you saw on your calculator, and then of course you would record the 8, 63 as your point of intersection. You are also to record tables for these graphs, and since we basically took our equation and turned it into 2 separate functions with an intersection, so we were really treating it like a system. So our table, which is to display the solution and then 1 point before and 1 point after to help you see these relationships in a tabular way. Our solution was at 8, so we're going to look at 7, 8, and 9 as our x coordinates. And for the first equation, the left side gave us 58, 63, and 68. And the right side gave us 54, 63, and 72. Now I'm not including in the video here an actual shot of what the table looks like, but the tables display so differently in the calculators, I didn't want to confuse you by including that in the video, so we'll go over that as you need assistance with it. Alright, there's one more way we're supposed to graph, and that is to, instead of graphing each side separately, we then are to graph with all the terms moved to one side, as you see displayed here. So when we do that, this is the graph we see. And again, we expect 8 to be our solution, and it does show up as our solution, but now it's with 0. And what I want you to see in doing this set of problems is that a lot of times it's advantageous to put all the terms on one side and graph it, because you can always get to the x-axis easier than you can some random point of intersection out in the middle of nowhere. So we're going to copy this graph as well, and I don't really care whether you include the detail back on this side over here that really has nothing to do with the graph, but you probably want to include the y and x axes here with the line for reference, just to get the significant parts of your picture. And it's good to always label your axes. I didn't do that on the last one, but you really should, and especially when you're graphing horizontal and vertical lines, but that's just good math practice. So put a little arrow at the ends of your axes, label this X, label this Y, and we're going to go out. This one's actually going to be easier to do. 1, 2, 3, 4, 5, 6, 7, 8, because we just have one point to consider and one line to graph. And I'm not particularly worried about whether or not it's perfect in terms of its slant for the purposes of this lesson, but you want it to be sort of a rough approximation of what your graph looked like with the point labeled. And there's our point. So that's example 1, and that is the one to use to do 1 through 5 by from your sheet. Now let's go on to example 2, which is for 6 through 9. So the first thing we have to do is solve analytically or algebraically, and this is an absolute value equation. So the first step of solving any absolute value equation is to isolate the absolute value expression itself. Well, in this case, it's not isolated because there's a -5 outside the bars. So we're going to add 5 to both sides to eliminate that -5. And we're going to get the absolute value of 3x plus 4 equals 11. And then, once we get the absolute value term isolated, then we're going to break it apart to get our two solutions. The first equation always looks exactly like the equation, just drop the bars, and that makes sense in the definition of absolute value, that when the number inside is positive, it's the same thing as if the bars weren't there, as if the absolute value was not involved. But then you take the inside and set it equal to -11, and we're going to get a different result because of the fact that the inside is now -11. So we subtract 4 from both sides, and then we get 3x equals 7. We divide both sides by 3. We get x equals 7/3. We do the same steps on the second equation, but we're going to get a different result because we started with a different right side, and we get 3x equals -15. Divide both sides by 3. And we get x equals -5. So now we have two solutions to work with. So we're going to go to our graphs, and in the upper left corner again you see the unzoomed version, the standard zoom view of the graph when you solve it in a standard window, and you can barely see your intersection points up there. So I just rezoomed. You don't have to if you don't want to. As long as you can see the intersections, your calculator will determine those intersections for you if you go through the steps as outlined in your packet. But I've moved it down to where you can see it better. It's more centered in the viewing window. And we have 2 points of intersection, -5, 6, and 2.33, which I would prefer you think of as 7/3, by the way. 6. And obviously we would expect the y-coordinates to be 6 because we're intersecting a horizontal line with the setup of the two sides as separate functions. So we'll complete our table for this graph. And again, this one's going to be a 3-column table because we treated this equation as two separate functions, which in essence became a system. And so, in fact, let's go left to right. So we'll start with -6 because we want to go one step to the left of the 0 and one step to the right to get a bit of a short table for each side or each solution. And then we'll just call them y1 and y2. And our y2, since when I put it in my calculator, I put the 6 in as my second equation. Those are going to be 6's all the way down. So I'm going to go ahead and set that up for the other solution as well. And obviously our solution in both instances, would be 6 to get the y's equal, which is what the solution to the system is. And at -6, we need a 9, and at -4, we need a 3 for the y-coordinates of the first part, the left side, and where the left solution is. And then the other solution on the right is our 7/3. And I set my table up in my calculator using the table settings to get this value, but when you have to do that to get a fractional value, just go back and get the integer preceding and the integer following as your previous and next values. If you want to write the other decimals, that's fine too. So at 2 we have 5, and at 3 we have 8. So there's the table for that one. And then one more step for that equation is to move all the terms to one side and graph it. And no surprise, when we do that, we get an absolute value graph, because obviously we could combine that -5 and -6 to -11, which if you think about vertex form means that's just where the vertex is going to land, the y-coordinate. But for our purposes, we're going to go ahead and do the table now that we see our solutions. Again, you're going to go through the steps to get your calculator to tell you those solutions. And on the inspires, you'll see the same way you see here. If you have any other kind of calculator, you're going to see, I think, an x equals and a y equals down at the bottom of the screen. But let's go ahead and do our table. One more thing I meant to mention before I record the table with you is that you'll notice in these displays of these equations that I didn't bother simplifying to -11 when I put it in the calculator, because I wanted to show you that when you're in the process, all you want is the graph itself. You don't need to do extra work to get it in the form. Just move all the terms over like I did here and leave them separate and let the calculator do the math for you. Again, always working smarter, not harder, to get where you want to go. All right, and in this case, again, we're going to have a long, skinny table because we've boiled it down to one equation again. So on the left side, where we have our -5, 0, one step to the left of that would obviously be -6. So we have -6, -5, -4, and our 3 y values around that vicinity are 3, 0, and -3. And I will leave it for your group discussion as to why those values make sense relative to this equation. And then the other set of values are for the positive solution, which was 7/3. And when you're in graph mode, even your inspires will always display your answers as decimals. But I prefer the improper fractions. And the smallest value, integer value to the left of 7/3 would be 2. The smallest integer value to the right would be 3. And of course, we're going to have a 0 at 7/3. And we're going to have a 1 at 2 and a 2. I'm sorry, that was a -1 at 2 and a 2 here. And again, notice what happened on this side of the table and on this side of the table that made sense relative to our equation. And I'll give you a hint. It has to do with the 3x inside the equation. And that ends our video for these two examples.